The corrosion is heavy on the breech, but the trail legs look stable enough for the lift. Let's secure the elevation mechanism first.
Take the tension. Hold steady on the hoist. Let's bring her up.
As you can see, the threads are totally frozen. We'll use the induction heater to expand the housing and hopefully free that pin without causing further damage. The induction heater creates eddy currents, heating the bolt from the inside out. That thermal expansion is exactly what we need to break the rust bond. Meticulously cataloging every component is crucial for the eventual reassembly of this lost technology. The corrosion here is significant. We'll use the induction heater to expand the housing and hopefully free the locking pin. The induction heater causes rapid thermal expansion, breaking that corrosion right at the molecular level. Now we should be able to turn it.
All right, heat's applied. Let's see if the impact wrench can break it free.
We're looking at the sliding breech block here. The corrosion isn't as bad as we feared, but these valves are completely seized. This induction cleaning is crucial. It allows us to clear decades of marine growth without damaging the underlying metal structure. That's a perfect fit. The laser sintering process really nailed the tolerances on this one. The chemical dip creates that perfect blue-black patina, essential for preserving these steel components. Buffing the steel ensures a deep luster and seals the protective coating. It's meticulous work, but the results speak for themselves. The matte finish is crucial here. It absorbs the light, reducing visibility on the battlefield. All right, the breech block slides in smoothly. Now we just check the tolerances before we test the elevation gear. All right, the pressure's holding steady right at the service limit. This cylinder is ready for reinstallation.
You have to hand start these heavy nuts. Cross-threading the axle out here is the last thing we need.
The contrast between the matte green carriage and the blued steel fittings is exactly what we aimed for. This piece is finally ready for display.
Look at that. Smooth as silk. She's finally ready for the next phase.
Okay, the sliding block is clear. We have 0 obstructions inside the chamber. And that's the last piece, fully restored and ready for the museum. Another piece of history saved.
That's secure now. Make sure those chocks are tight against the rubber before we start the lift.
Absolutely perfect alignment. This cannon is officially cleared for reassembly. And that's exactly what we wanted to see. The mechanism is fully restored and moving freely.
We have to make sure these buckles are tight. Any moisture gets in, we lose the lens. That's it. After 6 months, the Howitzer is finally ready for display.
This initial scrub is crucial. We're clearing the heavy corrosion before we can assess the metal underneath.
We use these thick rubber mats to protect both the hangar floor and the leading edge of the trail spades during the structural assessment.
All right, the outer diameter is exactly as specified. We have perfect tolerance compliance here. All right, that's perfectly aligned. The reticle is sitting dead center on the target.
Sensors attached, bringing the pressure up now. We need a steady 2,500 psi and absolutely no seepage at the bleed valve.
The specialist applies the blued steel cap, protecting the hydraulic port from further corrosion before reassembly. The specialist applies the matte finish to the salvaged cannon, carefully preserving the original military serial numbers for historical record. Maintaining a clean workspace is critical, especially with dealing with artifacts this sensitive. The Howitzer is almost ready for the next phase. The gauge confirms the pressure. Now we'll tap the tread, listening for inconsistencies in the rubber density.
Careful maneuvering is essential when relocating these heavy artifacts across the hangar floor.
And that is full elevation. The gearing is sound, the brake holds tight, she's ready. After months of work, she's finally ready. Perfect.
With the day's work complete, the heavy machinery is powered down and locked out. Ensuring the site is secure is paramount for the next phase of restoration. The chemical bluing process provides essential corrosion resistance for these recovered parts. We have to be meticulous. Securing the component with a protective canvas is crucial to prevent further corrosion before the laser ablation can begin. It took 3,000 hours to get to this point, but we've ensured its legacy for the next generation.